In this course, we are not going to understand how to calculate limit. That your coaching institutions or textbooks can explain you better. We are going to understand what exactly are limits and what does it geometrically mean. First of all, limits of what? We calculate limits of function. Why are limits evaluated? See, sometimes the value of function at x equal to 8 turns out to be one of the indeterminate forms. Like, what are indeterminate forms? Like 0 by 0, 0 multiplied by infinity, infinity upon infinity, infinity minus infinity, 1 to the power infinity, infinity to the power 0, 0 to the power 0. At these points, the function is not defined. So we use a limit to know the behavior or understand the behavior of the function in that immediate neighborhood of x equal to 8. We are now going to understand what is limit. See, by intuition, limit is the value of the function that the function approaches as x approaches some value. Before we understand the technical definition of limits, we need to understand the concept of something being infinitesimally big or small. When something is infinitesimally small, it means that the value approaches very, very close to 0, but not exactly 0. Something being infinitesimally big, that means that the value is a very big number which we cannot measure, but it is not exactly infinity. So when I say limit x tends to a for x equal to h, the value of h will be something infinitesimally close to a. Here we have an example of a quadratic y equal to x square or f of x equal to x square, and we are asked limit x tends to 0 for f of x. By observation, we can clearly see that h equals to 0. And if we are asked x tends to 2, by observation, we can check that h equals to 4. A limit x tends to a f of x is said to exist if x tends to a plus equals to x tends to a minus equal to a finite quantity. A plus means that we are approaching that a from a positive side of x-axis, and a minus means we are approaching a from the negative side of x-axis. Means if we say 0 plus, that means we are approaching it like this from this side, and if we are saying a minus, that means we are approaching it from this side. Am I clear? Okay. If we see in this function, we can see that for 0 minus we have value something close to 0, and for 0 plus we have something close to 1, and hence it is not satisfying this criteria and this function limit is not defined. Use of limit, that why we are using this limit, we are going to understand in this example. We have a function x square minus 4 divided by x minus 2. See the graph of this function, we can see that at 2 this function is not defined, undefined, but we have to understand the behavior of this function at x equal to 2. So for this purpose we use limit. Limit of x tends to 2 equal to 4. How we calculated this? We can see in the immediate neighborhood the function approaches 4. Similarly, several indeterminate forms can be calculated using limits. Okay, that's it for now. Thank you so much.